Milo comes on a precision rail system, and we can move the track like this. We can lift up and down. We can rotate. Some people call that boom. We have an additional axis that many rigs don't have. We have an extend. We additionally have an axis here which is called angle, and at the moment this has been set to treat the camera as a parallelogram system. So when I lift, it stays upright. We have pan. We have tilt. We have a roll. And I've also got in here the capability to run focus, zoom, and iris, all from my flare system. So all in, this is a 12-axis system that we're looking at here. And flare has no problems running that number of axes all together at the same time. I have here a move already worked out, so I can go to my start. And I can shoot it. This is a very precise machine. It's capable of shooting from a 3 meter a second tracking shot. That's 10 foot per second, okay, to a 100 millimeter macro going through 1-to-1 magnification, producing smooth movements at those magnifications. It's a very rigid machine. You can't do that with many motion control rigs these days and get away with it. And because it is a very rigid machine, you can do repeat pass compositing that is frame accurate at HD resolutions and do straight compositing from that data without necessarily having to edit or track or smooth in order to have things match. Stuff that you film with this, if it's properly set up, will match. One of the advantages of the Milo is the number of additional axes that we have. As an example, we can go very high. And while we're up here, we can do pans, we can do tilts, we can roll our camera. And we can do the usual booming around. And we can come up and down. And we can have this as a start or an end position of any of our moves. Going to come down now. We were able to do that because we've got this angle here. And we've got an extend here. They're both additional axes to a normal machine, as well as the track that we've added now. In order to handle these better, we also have a capability to go into roll level. Roll level keeps our horizon level, whatever the shot. And then, of course, if I really need to, I can go into a head level situation where I can treat it just like a parallelogram system with the advantages of ease of lineup, ease of shooting, and maintaining our pan and tilt axes doing what they would normally do. These extra axes are, of course, in our kinematics model. The kinematics model that we're using here is a Milo kinematics model. We have a track, a rotate, a lift, an extend, an outer arm or angle, a pan, tilt, roll. And one of the features that we are looking at here that is different from our bolt system is we have a roll, which we can roll, and that axis is mounted straight behind the camera. So this is an end mount camera. On the bolt we were using a top mounted camera. Here we are using an end mounted camera. This is the factor that changes the nodal offset measurements for a lens on the bolt as compared to a Milo. When we were measuring nodal offsets to do focus setups, we noted that the Milo nodal offsets are different from the bolt nodal offset. This is why, because our camera is end mounted. Our kinematics not only contains what axes we have and what they are doing, but it also includes all the measurements of the sizes of the machine. And these are all accurately chosen to precisely show the shape that we have on our Milo. Because of the accuracy of these, we are able to export information from the Milo to a 3D package and thus use this information to line up CG backgrounds or even pre-visualize something to shoot in the Milo and import it and have it accurately reproduce that pre-visualization. You see here we have a switch. It says master track, master extend. The master track was the setup that we needed in order to be able to work with rotate near 90 degrees in Cartesians and target tracking. If we're not working in Cartesians or target tracking, we don't have a problem going through 90 degrees rotate. But if we are using Cartesians or target tracking, as most work with this machine would involve, we need to be able to decide, is my track a master or is my extend a master? If my extend is a master, then the extend will not move as part of target tracking and acts as an independent axis, but overrides the capability of the target tracking calculations. I'm going to put it back to master track because I want it to be there for this next item that we're going to be looking at. I'm in a position there. I'm going to come around a little bit and I'm at an extend position, pretty well in the middle. I'm at a camera position. I'm locking off that camera position. My focus is turned on. My target distance, I'm going to set a target distance of 2 meters there. And I'm going to go into a Cartesian situation. Do the go to. So I'm now in Cartesian mode. I'm in head level because my angle is set to keep my pan upright. And I have normal Cartesians functioning. And you may note that because my track is a master, my extend is the axis that allows me to move in Cartesians. And of course, the interesting facet of this is that if I want to use my track while I am in a Cartesian setup, of course, I will not be moving the camera. So there I have moved my master axis, which defines the Cartesian calculations, but I'm not moving my camera because I haven't told the camera to move. So here I'm moving my master axis and I am shifting my rig and my camera is staying still. This is a very useful function if I need to plot a smooth and well thought out movement in order to have as fast and smooth a movement as I need. I may need to move the body of the machine from position to position in order to be able to better do my moves. If I now go out of my head level situation, so my angle is also available for me to move, my angle also is, if I look in my setups, a master axis, which means that were I to move it, the camera isn't moving in space. I'm going to turn on roll level so that my roll stays level while I do this. I can now shift my angle and my track, which may be a necessary function in order to more easily handle a position that I am programming. This has been a Mark Roberts motion control training video. Thank you for watching.